This video is on rate of change and slope. The rate of change describes how one quantity changes with respect to another. It is defined as the ratio of the change in the y value, that is the dependent variable, to the change in the x value, that is the independent variable. So the rate of change is equal to the change in y divided by the change in x. Here's an example. The graph below shows theme park attendance in millions for the years 2000 through 2006. So to calculate the rate of change in park attendance for the years 2000 to 2002 is going to be the change in y, and you'll notice that in 2000 my y value was 317 million, and in 2002 my y value was 324 million. So I do 324 minus 317 divided by my change in x's, and my x's are 2002 and 2000. So that's going to give me a rate of change of 7 over 2, or 3.5. This means that for those years, theme park attendance increased at a rate of 3.5 million attendees per year. Notice that the rate of change is not the same for all of the intervals of years. So for example, between the years 2002 and 2004, attendance increased by only 1 million. So that represents a rate of change of 500,000 attendees per year. Notice that this part of the graph is also not quite as steep as the other parts. Oops. There you go. If the rate of change is constant, that is, if the rate of change is the same over the entire relation, then it is a linear function and its rate of change is called slope. So the slope is the change in the y-coordinates, which is sometimes referred to as the rise, how much it grows or falls in the vertical direction, divided by the change in the x-coordinates, which is sometimes called the run, which is kind of the change in the horizontal direction. Here's a little text box, a concept box from a textbook that describes the slope of a line. So if we have 2 points, and we're going to call one point x1, y1, and we'll call the other point x2, y2, it doesn't really matter which is which. To calculate the numerical value of the slope, you're going to do y2 minus y1, that's your change in y, divided by x2 minus x1, that's your change in x. So let's take a look at an example here. We need to find the slope of the line that contains the points -3, 7 and 3, -1. And I chose one here that's actually on a graph so you can see what it looks like. So I'm going to go ahead and label my points just to kind of keep things clear here. I'm going to label this one x1, y1, and this one x2, y2. And those 1s and 2s are little subscripts. They're written kind of lower. Now the formula we had was the slope equals the change in y over the change in x. So I can just go ahead and calculate that by plugging in the numbers. So I have -1 minus 7 over 3 minus a -3. And remember, subtracting a negative makes it a positive. So that's going to give me -8 over 6. And then simplifying that fraction gives me a -4 over 3. And you can put your negative sign on the top, you can put it on the bottom, or you can put it out front. Let's see what that looks like with respect to the graph here. So what this is saying is the change in the y is 8 units. So basically we were going down, how far did we go down? Down to here. And if you were to count, that would represent a -8 since we're going down in the y direction. And then from there over to here, that would be a +6. So your rise is a -8, that's your vertical direction. Your run is a +6, which translates into -8 over 6 or -4 over 3. Here are a couple practice problems I'd like you to do right now in your math journal. So if you could stop this video and try these 2 problems in your math journal, and then I'll come back and show you how to do them. Okay, the first practice problem says find the rate of change represented in the table below, where x is the number of floor tiles and y is the area of the tiled surface, the surface that's covered by these floor tiles. So to find the rate of change, I'm going to pick 2 points here. So I can represent this first row as 3, 48, and I'll just pick the second one, 6, 96. Okay, and I'm going to go ahead and do my change in y, which is 96 minus 48, over my change in x, which is 6 minus 3, so that's going to give me 48 over 3, which is the same as 16 over 1. So what does that mean? This means that my rate of change is a positive 16, which means that for every floor tile that I add to the floor, it adds 16 square inches of tiled surface. My second example here asks me to find the slope of the line that passes through these 2 points, and I'm going to go ahead and label them x1, y1 and x2, y2, and my formula is m equals y2 minus y1 over x2 minus x1, and I'm just going to plug in the points here. So negative 2 minus a negative 6 over 4 minus a negative 4. Remember that subtracting negatives, I can make both of these positive, and that's going to give me 4 over 8, and then reducing that fraction, that gives me 1/2. So the slope of the line through those 2 points is 1/2. And one last thing I'd like to talk about is, here's another box from a textbook, which kind of summarizes what slope is. If a line has a positive slope, then it's going up as you read from left to right. If a line has a negative slope, it's generally going down as you move from left to right. If the slope is 0, that's going to be the slope of a horizontal line. So you'll notice there's no rise over the entire run. So that would be a fraction like 0 over 8. And then a vertical line has an undefined slope because this relation is not actually a function. You might end up with this if you have something when you calculate the slope. It might be something like 8 over 0. And remember, you can't divide by 0, so we're going to use the word undefined to describe that slope. So in this video, we took a look at rate of change and slope and saw that they were both basically the ratio of the change in the y over the change in the x.